Alright, so as we get this chapter started, I just wanted to bring to your attention kind of the pattern of what's going on here. Again, guys, first of all, I can't stress it enough here. You'll need notes for this chapter test. I do not expect you guys to remember formulas. When you're out there in the real world, you're going to be able to look things up all the time. What I do ask for this class, though, is that you put forth the effort into taking the notes as we go through these sections and keeping them nice and organized. That way when we get to the end of this chapter, and as you can see it's a very short one, it should take us no longer than maybe 6 or 7 days of class time to get through this chapter. So you'll want to have nice, neat, organized notes. That way when we get to those quizzes and tests this chapter, you can just access them and use the formulas and just be done. So we'll go ahead and get started on 4.1 today, areas of parallelograms. Now, again, hopefully we've already done the chapter for prerequisite skills, and I'll write it up on the board and I'll put it in the calendar to remind us as well. So make sure you do those prerequisite skills before you start doing these assignments. As far as today goes, it's actually very simple. Areas of parallelograms are going to be kind of easy to figure out because it's the same as the area of a rectangle. I'd like to draw your attention to this picture up on top of the blue parallelogram. A parallelogram, before we get too carried away, is just a four-sided shape that have opposite sides are parallel. So we know that the bottom and the top are parallel, and we know that the right side is parallel to the right side is parallel to the left side. The reason it's so easy and we can say the area is equal to the base times the height is that if we take this triangle that's split off this parallelogram by this red line and we transpose it over here, meaning move it over to the other side, it would just be a rectangle. So we know how to find the area of a rectangle. It's simply length times width. And so we can see that example 1, A and B is very simple. We just need to take the base on both of them and multiply them by the height. So the base on number 1A is 12. So I would say 12 times the height is 14. And I would multiply those out, 12 times 14, and I would get 168 meters squared. Area is always in meters or units squared. So the next one, B, it's 4 for the base and 8.5 for the height. We should know how to multiply fractions. If I take 8.5 and I make it a mixed number, it would be 17 over 2 times 4. And I would cross the 4 and the 2 out, and I would take 17 times 2, and I would get 34 in its feet, and it's squared because it's area. So 34 feet squared is the answer to that one. Okay, now we have 3 practice problems. Again, it's kind of blurry. The base on number 1 is 20, the height is 25, the base on number 2 is 7, the height is 18, the base on number 3 is 20.5, and the height is 30. Make sure you put your units in units squared and try these on your own. Again, hopefully you've had time to pause and try these on your own. If you haven't, go ahead and do so, but I'm going to go ahead and work them out. Number 1, again, base times height, we're going to take 20 times 25. We multiply those out. Let's see. 500 would be your answer. And since the unit of measurement is meters, it's going to be meters squared. Number 2, we have 7 for our base times 18 for our height. Let's see, 7 times 18, we get 126. And it's in inches, so we're going to put inches squared. Next one, our base. Our base is 20.5 times our height is 30. So we take 20.5 times 30, and we get 615 yards squared. So again, guys, it's simple. Just take base times height and you multiply, and you'll be able to do these pretty quickly. Example 2 is going to give us a picture on a coordinate plane, and a lot of it, you guys, is just counting and being able to see the units of measurement of our shape. So the 2 key things to remember is that the base and the height may not always be a straight line through our shape. and sometimes the base and the height might not even touch our shape. So the base is always going to be the actual point to point of the bases. The base on this one is 2. I'll try and make this a different color. Maybe you guys will be able to see it a little bit better. We'll put it up top. 2 is our base. And then if we look and we count from the very highest point to the very lowest point, that's our height. Our height doesn't have to go through our shape. It doesn't have to go diagonally. Well, it can't go diagonally. And it doesn't have to go through our shape and stop at a point where it touches. It's the highest point to the lowest point. That's the height. So if we count 1, 2, 3, 4, 5 is our height. You can see that illustrated over on the right also. Here's how your book would illustrate that. Again, area formula though is very simple. We just say area equals base times height. We plug in the base, 2, times the height, 5. We multiply it and we get our answer, 10, and we're going to put units. If I could spell units correctly, let's try that again. Units, there we go, squared. So, again, you're going to have some like that. This is the exact same type of problem. So what you're going to do is pause, try this, and make sure you guys can do this on your own. Keep it for your notes, and that way you can use it on a test. So again, we want to count the base and the height of our shape. So hopefully you've done that by now, but we have 1, 2, 3, 4 for our base. And again, the height is from the highest point to the lowest point. And if we count that off, 1, 2, 3. So our base is 4 times our height, 3. We multiply those together, we get 12 units squared. Sorry this last one is a little blurry. We will have some things like this from time to time where you have to figure this out, and this is in the book and you can see it a little bit better in the book, but the picture on the video is going to be a little bit blurry. But I'll read it here for you and we'll go through it together. You make a photo prop for a school fair. You cut a 10-inch square out of a parallelogram, and it says, of a parallelogram-shaped piece of wood, what is the area of the photo prop? So we want to find the area if our photo prop is 10 inches. We want to figure out the surface area of this parallelogram with that 10 by 10 thing cut out of it. So what we're going to do first is we're going to find the area of this parallelogram in feet. It's 4 times 8, and when we multiply 4 times 8, we get 32 feet squared. And honestly, for the sake of this problem, you guys, here's what I'm going to do. We're going to find the area of that square, which if it's a 10 by 10 square, it's going to be 10 inches by 10 inches. And so we have 100 inches squared. So now what we have to do is we have to figure out how much surface area 32 feet squared is. What we have to do there is we have to take 32 and we have to multiply it by 12. For each unit of measurement that was feet. So for example, there was 4 feet there. We had to multiply it by 12 once. There was 8 feet here. We have to multiply it by 12 a second time. So really what we have to do is take this 32 and we have to multiply it by 12 2 times. So we're going to say 32 times 12 times 12. When we do that, our new unit of measurement for the entire plywood cutout is 4,608 inches. Then we're going to take away how much that face is that we're going to cut out. So we're going to subtract 100 inches, and you guys can see pretty easily here what we would get for subtracting. We would get 4,508 inches squared for that plywood cutout. So again, that one was kind of a lengthy problem, but if you ever have one like that, you guys, I'll help you set it up. Just make sure that we don't give up on those before we try. All this was we were trying to find the plywood cutout surface area minus the face. So that wraps it up for the 4.1 video. Go again to the calendar. Again, make sure this assignment is done when we come back tomorrow. That way we can continue on in the chapter.